Hello.
Homework numero tres.
Yeah, let's go.
Kinetics and collision theory.
Oops, sorry.
What's the order of operations in a chemical reaction?
Sure.
How does one even start?
Yeah. And you know what? There was a word that showed up in the POGL that is kind of a leftover question we asked. So I figured I'd bring it up right now. It's called rate determining step.
Right.
Let's throw it out there and just talk about what that is real quick.
Well, a rate determining step is exactly what that is. The step in a chemical reaction that determines the overall rate of the reaction. Meaning that if you have a bunch of series of math computations, like 2 plus 2, 3 plus 3, simple ones, but then you get to a step where you have to
Divide and conquer.
do long division.
Right.
That's going to take you longer period of time.
Right. So no matter what we do to manipulate the rate of the reaction, we're always going to be beholden to that one step.
Right.
So we call that, it's generally what we call the slow step.
Right.
The step that we just really can't do anything about. The other things we can manipulate mess with some of those other steps.
If you want to think about it in the sense of completing this whole packet, the rate determining step for most of us will be reading all the small passages, because that takes time. It's going to slow you down. Once you understand each small passage, each tiny little comprehension question might actually take you 5 seconds to answer. So the rate determining step in a POGL is doing all the reading and understanding your models.
There you go.
The questions in the summary, that doesn't take so much time.
Hopefully.
So rate determining steps determine the rate of a reaction.
Sure. And then, so now let's get into kinetics. It's just the study of these rates of reaction. How fast? Rate. The rate is important.
How much time does it take for this to complete? Can I speed it up? Can I slow it down? How?
Let's get this homework over with. That's
All
what
right.
you're thinking right now.
So we can manipulate chemical reactions by changing the conditions of what we call collision theory.
Okay. That sounds good, mister.
It is.
Okay. So these are some of the things that we can change.
Right.
We do need to know that ionic reactions happen faster than covalent reactions.
They have fewer steps.
Right, and less bonds.
And furthermore, the bond between two ionic compounds is extremely strong. So those two compounds, they want to react very quickly, and they can because that bond is very powerful.
Right, making them. Right, not necessarily breaking them, but making them, sure.
Well,
they're just a
so
much easy thing, right? It's, covalents get all these extra third bonds. We saw triple bonds.
Double bonds, triple bonds.
Yeah, it gets crazy.
Those bonds are weaker by themselves, but it takes longer to break them down.
Right. Then there's the number of steps in the reaction itself. Makes sense.
Less steps, faster reaction. If you got a worksheet for homework that's got 3 problems on it,
you're probably going to be done faster than the worksheet that's got 10.
There it is.
Right? Makes sense. A little bit of logic.
Yep.
Be good.
What is collision theory?
Now, these are the rules for any chemical reaction to occur. I got these 2 reactants, but how do I make them react?
Reactant A.
Reactant B.
How do I get a handshake to occur?
Well, first of all, if I don't touch hands,
we have to collide. We actually have to physically make contact.
And that really
not just contact,
like contact.
Contact.
Right? So it shouldn't go overlooked that we actually have to make contact first, and that's where we get this whole collision.
These particles got to bump into each other.
So that's the first bit. And this can't be understated. The collision has to happen.
Right.
First. Exactly. Then the collision has to meet some criteria.
So we have a collision.
Oh, yeah. Nah, not really feeling it.
Not really a good handshake. Got to have enough energy to
make it happen.
Make it happen.
Stick.
Because if 2 particles just bounce into each other real gently, one's going to just bounce off and they're not going to react. They have to have the right amount of energy.
Right. And then the correct orientation. So we go like this. This is really not a handshake.
Even though
really got to come in the right way.
Right. So again, not the right orientation, might have a lot of energy, but it's not really a good handshake.
Right.
Got to have all 3. Collision, energy, orientation.
Right. And you've seen this topic before, specifically with enzymes.
Yeah.
They had to fit in lock and key. So very much the same thing here. The right ends of the molecules do have to bang into each other
with the right amount of energy to make the reaction even happen.
And then when that reaction happens, we call that an effective collision. Right. It met all the criteria it needed to, and off to the races that reaction went.
Let's show them some ineffective collisions real quick.
That's no handshake.
Not a handshake. Effective collision.
Done.
Energy orientation collision.
Good. Reaction happened.
Mm-hmm. So the things we can do to manipulate those reactions.
Right.
So in a chemistry lab, we can do some things physically to our materials to make them have the right energy, orientation,
Right.
and collision.
Right. And so the first topic here is concentration. How much of the stuff per unit of volume?
Well, if you increase the concentration, you're increasing the probability of a collision.
Right.
Even if it's not a good collision, the fact that they're going to be more
Eventually there's one.
Eventually there's one. If you decrease the concentration, these particles are going to be more likely to zip past each other and not hit each other.
Right.
So there's a slower reaction. It's not that it won't occur, it just won't happen
As fast.
temperature.
So temperature is kinetic energy, which is
Low kinetic energy.
slow or fast. We get them moving faster, they should react faster.
Right, because they hit each other more often and with more energy. So increasing the temperature should make a reaction go faster.
Which is probability, and this one is actually double bang for the buck because not only do I have more actual collisions, with more energy, I should have the right amount of energy when I do collide.
Right. And so cooling down a reaction would slow down the reaction rate.
Correct.
Why your refrigerator keeps your food longer.
Right, because it keeps the reaction, which is the spoiling, from happening.
Slowing it down. It's not that it won't happen, it just slows
Takes
it
a
down.
lot longer. Right. Now, pressure is specifically for gases.
Because pressurizing waters and liquids and solids,
They're
doesn't really work.
incompressible,
Mhm.
but it works like concentration. So if you have 10 particles in this much space, they might hit each other, they might not. But if you pressurize it, now I squeezed them together, their
more
probability of hitting each other goes up.
Right.
So again, decrease the pressure will decrease the rate.
less likely to collide with each other,
Right.
and definitely would have less energy when they did.
Right. Now, surface area is the total area of the particles.
Right.
So I don't want you to get confused on this. The more particles I have, the smaller the particles get, because I have more of them now with the same amount of stuff, the more the surface area is increased.
Mm-hmm.
Doesn't seem like it makes sense because it's a smaller piece,
Right.
but now more of the inside is exposed. If you want to
Think about it like this. If you've got a piece of chalk and you crush it into a powder, there's more particles, so there's more surface area.
more contact sites.
That chalk, if it were to react with an acid, would react quicker as a powder versus as a chunk. So if you've ever got wicked heartburn, you take a Tums, you're supposed to chew it
not just swallow it.
and not just swallow it. You can swallow it, but it's going to get rid of your heartburn slower. If you
Right.
chew it into a powder, it reacts faster with your acid in your stomach and esophagus because of collision theory,
There you go.
and it neutralizes your heartburn.
More surface area equals more reaction sites. Now, a catalyst will increase the rate of a reaction, and then that's it. Catalysts don't decrease the rate of a reaction ever, and catalysts are a special thing. So I don't want you to think that catalyst is the go-to answer. They're very specific,
I can cut paper into small pieces with my fingers.
and his fingers are still there.
My fingers are still here. That's a reaction. I can cut paper much faster and more effectively if I use a catalyst.
Okay.
I'm still cutting paper, but I'm doing it much faster and I'm using less energy to do it. So the scissors in this scenario is a catalyst. It makes the job quicker with less energy, so it happens.
But the
faster.
reactant and the product is still the same. The reactant was a whole piece of paper. The product is now pieces of paper. We haven't changed any of that.
Nope. And the
Which is-
scissors are still good to go on another piece of paper later.
Hence, meets the definition of catalyst.
Yepper.
And that's it for our video.
That's it for this collision theory manipulatables. Know how you can change the rate of a reaction.
Yeah, and specifically know what collision theory is so that you figure out how you manipulate that.
I mean, there's only three things.
That's really it.
See it?
See it.
Buttons. I push them.